Hello, this is myself Aishwarya and my teammate Harish Reddy here to explain a project regarding anomaly detection and network traffic analysis. Have you ever heard of the target data breach which happened in 2013? It was an incident where customers' data of about credit and debit card accounts were leaked, where hackers gained access to the target's network using credentials stolen from a third-party vendor, and they installed a malware on Target's point of sale systems, capturing the customer's debit and credit card information. Additional information like which includes their names, phone numbers, emails, mailing addresses of up to 70 individuals were also leaked, where Target faced a substantial financial loss, which estimated over $200 million, along with the lawsuits of loss of customers' trust and resignation of CEO and CIO. So, why is anomaly detection more important? For example, you're in a building and accidentally the building gets fire. Smoke alarm is a device that alerts you about the problems that you might not be able to see, providing an opportunity for you to act before they escalate. Similarly, anomaly detection is a process of identifying unusual patterns or behaviors and data that do not conform to expected norms, often signaling errors, frauds, security breaches. It is also crucial because it helps in identifying patterns or activities that deviate from the norm. Moving on, our data is from NASA's Kennedy Space Center's web server data, which consists of 2 months worth of HTTP requests, which dated back to August 1995, featuring a comprehensive array of weblog records like requesting host, date, time, request type, status code, and response size. Before performing an analysis, we performed an extensive data pre-processing, which includes addressing of missing values, converting the data types, and extracting key features that are required, such as required types and segments for more detailed analysis. Moving on, we performed an extensive data pre-processing, which include missing values, addressing the missing values. We address missing values through the data pre-processing and extract and the features were formatted. To understand more about the data, we performed an extensive data analysis, which includes the data visualization to explore more about the data. And we created a new features out of the existing features for model fitting, where feature extraction comes into play, which involves selecting the specific attributes from the datasets for model training. In our code, we extracted features like request length, hour, and day of the week from the web log data, along with response size and HTTP status for our model. The prime purpose of this is to simplify the data into a form which is more manageable and effective for our analysis. For instance, extracting the request length and response size helps in focusing on key features that are relevant to our model. Handing over the presentation to my teammate.
Thank you, Aishwarya. So to do our anomaly detection, we have used a model called isolation forest. So let's look at an overview of this algorithm. An isolation forest is an unsupervised learning algorithm used for anomaly detection. It isolates anomalies instead of profiling normal data. So what it means, not profiling normal data points, but isolating the anomalies. It means that based on a GET request from a weblog entry and the response time that it takes, it flags the entries and it is flagged as an anomaly. So in the functionality of the code, the model is trained with features like response size and request length to identify anomalies in the weblog data. Assuming a contamination of 0.01, that is the whole proportion of the data points that is expected to be outliers. So to look at our isolation forest's performance, we use a metric called F1 score. F1 score in anomaly detection, a measure evaluating the accuracy of the isolation forest model balancing precision and recall. So model prediction. The model labels data as 1 for anomalies and 0 for normal instances. So 1 is the anomalies where you flag all the GET requests that has a response size of over 400 or 500, or in our case, which is 300 and so. So how it is done? So here we create a true label. So what is a true label? Based on HTTP status codes, response size, and request lengths, we create a true label of zeros and ones that is tallied using a heuristic method. So the F1 score, how is it calculated? We use sklearn metrics. sklearn, scikit-learn is a library which has an inbuilt function for F1 score calculation. So this is used to compare the model prediction with true labels. The importance. It offers a comprehensive view of model performance, crucial for datasets with uneven class distributions. So it helps you say, if you have an accuracy of over 90% or so, you can be certainly sure that this is an anomaly. So that is how a F1 score works. So the results. The isolation model identified anomalies in NASA server weblog data with an F1 score of approximately 0.9, indicating a balance between precision and recall in the detection process. Visualizations reveal that anomalies are distributed across different hours of the day, days of the week, with notable concentrations at the certain times, suggesting potential patterns in anomalous traffics. So let's look at these visualizations right now. So this is the first visualization that we've taken. So here you see all the blue and red dots. So the red dots is ones that are flagged as anomalies. So you can observe that there are a lot of red dots or a response size of 1. That is basically 1 millisecond. And we can observe a significant amount of outliers right here. So that will state that these are the anomalies and the zeros which are not. So let's look at how the anomaly distribution is throughout the day. So we've taken it in 24 hours. You can look at the distribution. In the middle of the day, you can see that there's a very big spike in the data distribution. And with that, we know that there are a lot of requests that are being processed. And you can observe that there's a small hike in the anomalies that you see in the orange lines of the histograms. And you can also observe that at 6, you don't see any anomaly at all. It's a pretty small variation. So next, let's look at the conclusion of our presentation. So anomaly detection in weblog data reveals irregular patterns that are critical for system security and optimizing server performance. Isolation forest algorithm identified anomalies by isolating a typical data points with the F1 score indicating moderate accuracy. Data preprocessing and feature extraction, like HTTP status and response size, played a vital role in our modeling. Visual analysis showed anomalies distributed across different times of the day with peaks in midday traffic. The insight from this study can guide enhancements in web service security measures and severe server management strategies. Thank you.